Welcome to experience an out-of-dimension journey. D-Space One Time is here to make you a safari on maximally symmetric spacetimes. On the way, we like to visit these three universes: the flat, de-sitter, and anti-de-sitter. They are quite amazing to explore as they maintain maximal number of symmetry. The part 1 is to introduce these spots with their symmetries and the maximality. Let us start with the symmetries laid in D plus 2-dimensional flat universe with Q space and P time coordinates. The underlying symmetries can be decomposed into three categories. Translation. If we translate our coordinate system in any of space or time direction, interval remains invariant. This translation can independently be done in d plus 2 directions. Rotation. We can independently rotate either any two space axis or any two time axis, preserving interval. We can choose those two axes in QC2 ways for space and PC2 ways for time. Boost. According to special theory of relativity, spatial and temporal distance varies, but interval remains same under the change in inertial frames. The operation is called boost, which independently involves any one space and any one time direction. We can choose such combination in P times Q ways. Thus, in D plus 2 dimensions, the flat universe preserves d plus 2 times d plus 3 divided by 2 number of symmetries in total. To note, it does not depend on the number of time or space dimensions. In the discussion of maximality, two important questions arise here. Is there any other symmetry, or that's all? And if so, is the flat being the only guy that holds this maximality? To address these questions, let's focus on a measure called metric. The interval in a d plus 1 dimensional spacetime is determined by the geometry of the fabric, and the geometry is encoded in the metric. Here, G is the metric. Since the elementary components dx of the interval vector are commutable, G is symmetric under interchange of its indices. In matrix representation of the metric, two gray colored triangles indicate the symmetric components and blue inclined strip indicates the diagonal. There are d plus 1 elements in diagonal and d plus 1 choose 2 elements in one of the triangles. Since one triangle is forced to be the copy paste of the other by symmetricity, total number of independent components is d plus 1 times d plus 2 divided by 2, which is exactly equal with the number of symmetries in a d plus 1 dimensional flat universe. Symmetry is the independent degrees of freedom of choosing our coordinate system. The choice of coordinate system determines the interval components dx. To preserve the interval, the metric component should change accordingly. Thus, the maximality is justified. There cannot be more than d plus 1 times d plus 2 divided by 2 symmetries in our d plus 1 dimensional universe. Now, back to the d plus 2 dimensional flat spacetime. We can construct d plus 1 dimensional universe by defining a constraining surface in it. We like to talk about three such universes that preserve maximal number of symmetries. These universes have d space and 1 time. Flat. An 1D lower flat universe from a flat one with 1 time and d plus 1 spaces can be constructed by constraining a space coordinate to a constant value. In this diagram, time runs along the vertical direction. This constraint breaks one translational, d rotational, and one boost symmetry from the d plus 2 times d plus 3 by 2 symmetries, preserving the rest d plus 1 times d plus 2 divided by 2, which is maximal in d plus 1 dimensional universe. D sitter. And 1D lower DS universe, I mean D sitter universe, from a flat one with 1 time and d plus 1 spaces can be constructed by constraining the coordinates in a d plus 1 dimensional hyperboloid which preserves all rotational and boost symmetries. In this diagram, time runs along the vertical direction. This constraint breaks d plus 2 translational symmetries from the d plus 2 times d plus 3 divided by 2 symmetries, preserving the rest d plus 1 times d plus 2 by 2, which is maximal in d plus 1 dimensional universe. Anti-de Sitter. And 1D lower ADS universe, I mean anti-de Sitter universe, from a flat one with 2 times and d spaces can be constructed by constraining the coordinates in a d plus 1 dimensional hyperboloid which maintains all rotational and boost symmetries. In this diagram, two time directions are along the base sides. This constraint breaks d plus 2 translational symmetries from the d plus 2 times d plus 3 divided by 2 symmetries, preserving the rest d plus 1 times d plus 2 divided by 2, which is maximal in d plus 1 dimensional universe. These three universes are the interesting gifts from Einstein's general theory of relativity, which are important in cosmology and to study holographic dualities in quantum gravity. To watch their representations in different coordinates and project it on Penrose diagram, stay tuned for part 2.